Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. So first I'm gonna thanks to you guys for watching our video. So we're gonna present to you guys about Calculus 1 MIT 183. The topic is about application of differentiation, which is applied maximum and minimum. Before we start, we're gonna introduce ourselves to you guys. My name is Anisha Kira binti Muhammad Rizani, and my student ID is 2024646856.
My name is Nur Ain Syuhada binti Mat Suria. My ID student is 2024671704.
My name is Nur Danisa Dafina binti Muhammad Nizam. My marriage number is 2024651508.
My name is Iman Nurhanis binti Abdul Malik. My student ID is 2024237728.
So we're gonna start with introduction.
What is differentiation? Differentiation can be defined as the process of finding the derivative of the function. Differentiation can be used as a tool to calculate or study the rate of change of a quantity with respect to change in some other quantity. Differentiation are used in real life, such as first, differentiation in medical. Differentiation can be used to analyze medical image such as CT scan and MRI to help identify tumors and other disease. Second, differentiation in engineering. Differentiation is used to find rate of change of force or torque with respect to time, displacement or other variable. The last one is differentiation in business. Differentiation can be used to study how change in one variable affect another, such as how price change affect demand. What is related rates? Related rates are rates of change associated with two or more related quantities that are changing over time. Related rates problems involve two or more variables that change at the same time, possible at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time. Implicate differentiation is often used.
Okay, so why use related rates? Related rates are used to find how one variable's rates of change affect another variable's rate of change over time. Related rates are useful in many fields, including physics and everyday life. Example of related rates. First, the rate at which a balloon's volume changes is related to the rate at which air flows into the balloon. Second, the rate at which water's height increases in a vase is related to the rate at which the water's volume increases. And last, the rate at which the radius of a ripple in water increases is related to the rate at which the area of the ripple increases.
Problem statement. A tank in the shape of a right cylinder has a height of 15 meter and a radius of 7 meter. The water in the tank has been polluted and must be reduced until its limit, which is 1/3 of the tank, to fill in with the new and clean water. The water is being emptied by running it out through a hole at the bottom of the tank of constant rate of 0.5 meter per second. How fast is the water level falling until the tank is at its limit?
Formula for the volume of cylinder is V equal pi r square h, where r is the radius and h is the height. The question states that the tank's height is reduced to 1/3 of its original size. Since the original size is 50 meters, the new height becomes 1/3 times 50 equal 5 meters. Next, the relationship between the radius and the height is given as r equals 7/15 h, where 7 meters is the radius and 50 meters is the original height. Sustainable. This into the volume formula give V equal pi 7 over 15 h squared h. We simplify to 7 equals 7 over 15 pi h 3 squared. To find how the volume changes with respect to height, we differentiate V with respect to h, giving us dV over dh equals 7 over 5 pi h squared. Using the chain rule for rate of change, dV over dt equal dV over dh times dh over dt, and sustainable, the known value of dV over dt equals negative 0.5 m3 squared over x. We solve for dh over dt. Finally, the solution gives dh over dt equals negative 1 over 70 pi m over x, which is the rate at which the height decreases.
And the conclusion is we can use differentiation to find out how fast is the water level falling until the tank is at its limit. And we can solve the problem by using formula. And lastly, water comes out from the tank with constant rates. And these are our reference. Okay, that's all from us, and thank you for watching this video until the end. And hopefully this video will enhance your knowledge and provide valuable insights. Bye bye.